Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, it's February, and this month we're going to have quite a few customer-requested topics. Today is no different. Here is today's topic: more data sorting function blocks. A while back, we had a video where we introduced a whole number of user-defined function blocks for the purposes of sorting arrays. Sort up, sort down, all different types of data variables. Well, today we're going to add even more user-defined function blocks to expand even further the number of applications where you can use data sorting to solve your machine control. So without further ado, let's get started. We're going to get started by doing just a really quick review of the current data sort user-defined function blocks. We're just going to show you one example of the blocks that already exist to kind of refresh your memory. And then, of course, we're going to spend most of our time talking about the new data sort function blocks that we've added to the list. We're going to talk how you can apply those in the real world, and there'll be plenty of demonstrations. Here we go. Okay, so why do sorting? Well, we talked about this a little bit in the original video. One of the reasons you might want to do sorting is because more than ever, data is an important part of machine control. So capturing data, whether that's process data, whether that's performance data, on your machine can be a very valuable function. And when you do that sort of capture, very often sorting that data is also valuable. You might want to sort it to find the best and the worst results, maybe sort it for graphing purposes, whatever the case may be. Sorting data for data-intensive machine control these days is valuable. Now, I'm not going to cover the same ground we covered in the original video, so check this video out. In this video, I went through the original data sorting function blocks, talked about how they work under the hood, talked about the concept of a bubble sort, and there were plenty of demonstrations in that video as well. So I would encourage you to go back and check that one out if you haven't seen it, or if you need to refresh your memory. This is the last bit of review I'm going to do, and this is an example of one of the existing data sort user-defined function blocks. The one I have on the screen here is a sort up. We have sort up and sort down available. And the one I have on the screen is a sort up of integer data. We also have double integer and real data available to be sorted as well. So on the input side, there are 3 inputs. On the output side, there are 4 outputs. So you enable the function block, turn on the enable bit and leave it on. The function block will take the input array that you specify as one of the inputs. You also specify the length, how long that array is, and then it will effectively provide an output array of the sorted data. It'll turn on a bit when it's done, and it'll tell you how many times it had to pass through the data to do the sorting. That may or may not be all that useful to you in your application. And it'll also flag an error if you don't specify a proper length. And all these function blocks could handle arrays up to 100 elements in size. Okay, so that's just a quick review of the existing function blocks. Now let's talk about what we're adding to the list so you can do even more sorting in your application. Okay, so let's take a look at an example here on the right. So what we've got there is we have 4 variables, variable A, B, C, and D. All right, and in this example, what we've done here is maybe we're capturing, maybe each of those variables represents process data, and we've periodically captured a snapshot of those 4 variables at 5 different times. Index 0, 1, 2, 3, and 4. Okay, so each of those indexes, each of those rows in that table, if you will, correlates to a sample taken at the exact same time. So those variables are related in terms of when they were taken. Okay, so you can think of the index in this example as a sample number, if you will. So now let's say, how do we want to process this data? Well, let's say what we want to do is we want to sort variable A in ascending order, or do a sort up. Okay, and then we just want the other variables to be sorted so they correlate with variable A. Okay, so we're not going to sort the data within B, C, and D. We're only sorting variable A in terms of its value. But again, we're going to need to reorder B, C, and D based on the correlation with variable A. Now, if we use one of our existing sort function blocks, okay, we can easily enough sort the variable A array, no problem, and it'll spit back a sorted array in the proper order. If we want to sort it up, it spits back the data sorted up. However, the tie-in to the original index is not included in the output of those original function blocks. So with our new function blocks, and they're not replacing the existing ones, they're just additional ones you can use, because remember, that index may not be important in your application. But with these new function blocks, you not only get the sorted data, but you also get the original indexes that correlate to that sorted data. All right, so that's a big deal, because then you can use those indexes, if you wish, to sort your other columns so that you still have the correlation of each sample, variable A, B, C, and D. And even though variable A has done the sort, it has been sorted by value, B, C, and D have just been sorted so that the correlation remains. And we've got an additional user-defined function block called an index sort that allows you to do that easily as well. Okay, so that's effectively what we're adding. Let's take a quick look at what the new data sort user-defined function blocks with index output contain. The example on the screen is a double integer version of that, but again, we also have sort up, sort down, integer, and real types available. And this function block looks almost identical to the original ones, but the big difference is instead of having a field on the output side that tells you how many times you pass through to do the sort, instead it has an index array. So there's two arrays as output. An output array of the sorted data, just like before, but also an index array that's an array of the original indexes. So that is the new sort user-defined function blocks with an index output. The other user-defined function blocks that we've added are those index sorts that I talked about, where we can take maybe the results from that previous sort and we can use that to sort other data. So in this case, we've got an input array, which is the data we want to sort. But again, we're not sorting that data by value. We're going to sort that data by index. And so we've got another input array, which is just a list of indexes. And then when this function block completes, it provides an array of sorted data. Okay? All right. So that is what we're adding. So let's take a look at how these function blocks work on the bench. For our demonstration, we're going to start on the bench. Okay, so we have an initial array of data, okay, that we want to sort. And we want to sort that in ascending order. And we want to maintain, or at least keep track of, the indexes tied to each piece of data on the list. So we're going to use one of our new sorts with index output in this example. All right, so I'm going to go ahead and initialize the sort. And you can see that there we go. In this column, we have the sorted data, which is the output of our function block. And you can see it's sorted in ascending order, but we also received, in addition to the data, we also received a copy of the original indexes. All right, and we can use these indexes to sort other data that correlates to these original samples. All right, so let's go ahead and do some additional sorting, but this time using the indexes. All right, so here's our list of indexes from our previous sort, okay? And here we have two additional columns of data, or arrays of data, and we're going to sort these not by their own values, but by these index values here. All right, so let's start with the first array. All right, let's see if that worked well. The first one listed should be index 3, that's 28, there we go. Then index 1, that's 27, there we go. Then index 5, 26, there we go. All right, that worked like a champ. And now let's go ahead and sort the next list. And you'll see that it worked just as well here also. Okay, so again, starting with index 3, that's a value of 9940. There we are. And then on down the line, it's sorted just the way we want. So we can take that first sort that has the indexed output and use that to sort additional data. Now let's go into Cscape and see how we did this. All right, so here is where we call the original function block where we're doing a sort up, all right, with an index output. So that's ultimately the function block that we used here. Now, how did we add this user-defined function block into our project? Well, we went up here to Logic Modules, right-clicked and hit Import Logic Module. Once we did that, then the ones that we import will show up here, and they'll also show up here under user-defined function blocks in the project toolbox. Okay, when we drop one of those function blocks on the screen, in this case, this first function block that I dropped was this sort up double integer with an index output. All right, when I drop that on the screen, then I have to give it a name. You have to name each instance of your UDFBs, and I called this one test_d_index. All right, I assigned my variables, including the input array that I wanted to sort, as well as the resulting array of data and the resulting list of original indexes. Okay, so I just assigned these variables. All right, so that took care of our initial sort. And then our subsequent sorts are using the other function block that we introduced today, and that is the indexed sort. And when we dropped that function, each of those functions for the index sort on the screen here or in our logic, then again, we had to name each instance. So I called this one slave1 sort and this one slave2 sort. Now, the key here is that we are sorting by indexes, an index list. And here's the index list. And this index list is the same variable that was the output of this earlier sort. Okay, so because that was the basis that we wanted to sort these other two lists by. So the result index from here is our sorting index for both this function block and this function block. All right, so really pretty straightforward. Again, there are lots of applications where sorting is extremely useful, and this was just one of them. I've got another example for you, and this one is not related to data captures or process data or performance data or anything like that. This example is basically just a pumping example where we have multiple pumps and we want to select a pump to run at any given time based on machine hours or pump hours. How many hours has that pump actually been operating over its lifetime so that we can balance out the usage of each of the pumps. All right, so in our example, we have 4 pumps. All right, pump 0 through pump 3 is how you can think of it. All right, and we've created 3 different arrayed variables for the pumps. We have pump hours, which is a double integer, which literally just has the number of hours that each pump has been operating. We have an array called pump in service, which is an integer array where the low bit of the integer indicates whether the pump is currently in service or not. And then we have a pump selected array, which is another integer array where the low bit indicates whether that pump is currently the one that's selected or not. Okay, so those are the variables that we're using. Now, how's our logic going to work? Well, basically, we're going to start when it's time to select a pump. We're going to start by effectively sorting the array of pump hours from least to most, so in ascending order. And the output of that is going to not only be a list of the hours in order, but it's also going to be a list of the original indexes that correlate to those hours. So when we select a new pump, we're going to go to that list of indexes, go to that first index or pump number, and try and select that one. But we might not be able to because it might be out of service. So in that case, we'll have to go back up to the index list, take a look at the next one in order, see if that one's out of service or not, and you can see go on down the line until we find the pump with the least number of hours that's actually in service. All right, let's take a look at that on the bench. All right, so here is my logic for our example for our pump selection. And before we dive into this logic, let's take a look at what's going on the bench. All right, so we've got a pump selection page here where we'll manually kick off selecting the pump by pressing this select pump button here. Now, the pump that we select, we want the pump that has the least number of hours, but that is in service. All right, so let's put all the pumps in service. Okay, we've just got a toggle here where we say whether they're in service or not. So let's say that all the pumps are available to us and it's time to select a pump. Now, which pump do we think we want to select? Well, I would say we want the one with the least number of hours. That's what we've determined in this example. And it looks like the least number of hours is this guy. So let's select the pump and see what happens. Yep, the pump with the least number of hours has been selected. Well, let's say that one is out of service though. All right, and let's select again. All right, sure enough, the pump with the least number of hours of the 3 remaining, or the 3 that are in service, was also selected. And as you can see, it will always select the pump with the least number of hours that is in service. So this is working just the way that we want it to be. All right, now let's go back to Cscape and take a look at how we did this. All right, so effectively the heart of this system, or the heart of this logic, is our sort function with index output. Okay, and this is a sort up of double integer data. The pump hours is the array that we're going to sort, and it has a length of 4. And the output is the hours in order, but more importantly for our application, the indexes that correlate to those hours in order. And that's actually, the indexes are the key to what we need to use for selecting our pump. So effectively, after we have sorted and created this list of indexes, then we're going to deselect any existing pumps, and then we're going to go through and select the pump that we want based on that index list. So we're going to start by retrieving using an indirect move block, and we covered indirect moves last week, but we're going to retrieve the index number that's first on that list, the first index that's on the list of this array that was output from our function block. Okay, so we're going to grab the first one on the list, which is the pump number, effectively 0 through 3, whatever's first on top, and that will be our candidate. Okay, and then based on that candidate, we're going to go to the pump in service array, and using that candidate as an offset in the list, we're going to check to see if indeed that candidate is in service or not. So if we retrieve a 1 here, it means the candidate's in service. If we retrieve a 0, it means the candidate is not in service. And it's actually on the next rung that we're going to check for that 1 or 0. If it's a 1, it means it's in service. So then we're going to do an indirect move that's going to select our pump based on the current candidate. All right, and then we're done. Now, if it turns out that this pump is not in service, if that's the case, so this rung didn't happen, but this one does because the candidate was not in service, then we have to increment a pointer or an index and go back up to our list, okay, go back up here, and then pull the next candidate off of that list of indexes, all right, and then go through that process until we find one that's actually in service. So that's effectively how that logic worked. As you can see, it doesn't have to be a data-intensive application in order to use the sort function. All right, that does it for our technical content for today. If you're interested in OCS training in 2026, you can go to our website and sign up today. Now, we have one more course, an advanced course, available in the first quarter. The rest of the courses available in 2026 will be later on in the year, but there's plenty available. Get online and sign up today. There are lots of ways to interact with Horner online. You can do so on our website at hornerautomation.com. You can check out our YouTube channel where you'll find hundreds of videos like this, and the latest Horner news is always posted on LinkedIn. All right, next week, again, another customer requested topic. This time we're going to go through set points. What are set points in the Horner controller, the set point feature that is, and how can you use them? If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do some good.